DRDO, Bengaluru. Welcome, sir. Though he's not keeping well, we pray that and hope that he recovers soon. Thank you for joining, sir.
You.
Mr. Colonel Inderjeet Singh Barara is an eminent expert in cybersecurity and AI. Welcome, sir, to this forum on a short notice. Then Mr. Surit Hazra is the Business Director and the GM Defense India South Asia Honeywell. Welcome, Mr. Barara, Mr. Hazra. Mr. Abhishek Chopra is joining. He has joined from US and he's a founder and CEO of Boson QPSCI. They are working in the AI sector in different verticals, including the aerospace. Welcome, Abhishek, on board. We got connected about 2 days back, and now he's there on the forum. We look forward to listen to you.
Thank you so much. Really
And
appreciate it.
obviously, the session will be moderated by our most dynamic Colonel KV Kuber. Thank you, sir. I would like to update that we would like to thank the Technology Development Board, Department of Science and Technology in facilitating and supporting the series of webinars. This is one in the series of the role of artificial intelligence in defense. We just finished a webinar about 5 minutes back, which was on the funding mechanism for MSMEs in defense. And AI being a very important subject as the world is growing and developing, the warfare is also changing according to the changing times. And now artificial intelligence is obviously going to play some important role in the futuristic warfare. So what we are seeing today, that the role of artificial intelligence has been increasingly, it is increasing day by day. And for example, in the surveillance system or in the cybersecurity or in the simulation and training, in the warfare, in the logistics part, military intelligence, everywhere artificial intelligence is required. Even India is taking some measures to incorporate AI-based technology in its military and the surveillance systems and the surveillance projects also. We know that in 2019, I think Ministry of Defense formed the Defense AI Council, sir. You know that's also, and I think this is with the objective of promoting AI adoption in the defense sector. And for in today's webinar, we'll certainly like to discuss, and the all the panelists would discuss on what aspects, different aspects of AI in defense, and how do we see in the next coming decade or so how AI is going to shape the whole warfare system and the defense system of the world, especially with respect to India. I would like to hand over our discussion, this whole platform, to our only and dynamic moderator, Colonel KV Kuber, to take it over and take it forward. Over to Colonel Kuber.
Thank you, sir. Thank you, Dr. Nasir Jamal, and thank you for giving us that overview and introduction and bringing some excellent experts on board. I think that's the charm that you always bring into these events. And I also would like to welcome our panelists to be here amongst us this morning. I just want to say that are you able to see me? Are you actually able to see me? So
Right,
I'm not what I am.
Yeah.
I'm not what
we
I
are
am.
able to see you. We are able to see you, Colonel.
So, but I am not what I am. So
Okay.
this is 2025, and there is a bot. I programmed a bot. I created a AI program and created an algorithm. And therefore, what you see is it will look like me, but actually it's not me. So there'll be a bot that will actually conduct all these seminars. And while I'm relaxing somewhere on the beaches of Kandy, there is a seminar going on here on my behalf. My bot is actually representing me. So I just fast forwarded it to 2025, and Inderjeet will talk about it when he talks about this, because he's an expert from the Corps of Signals who's excelled himself in this particular field. So, ladies and gentlemen, AI in military is becoming far important, and AI-powered systems are better able to handle data efficiently. So, I commanded an electronic warfare battalion in operations, and I can tell you, one of the basic problems we always faced was information overload. And there are so many frequencies out there, so many conversations out there. can somebody filter it and bring it in front of me? For me as a commanding officer to listen, or my company commanders to listen, or my company havaldars to listen. So that was one big challenge, and therefore in this AI can play a very important role. We can program it to get hold of certain frequencies. We can program it to get hold of certain voices. We can do fingerprinting on on various on conversations that have been received. And with all this, so AI plays a very important role over there. Cybersecurity again plays a very important role, because that's where you can anticipate, you can actually prevent a lot of these attacks on critical military information and military system damages. We can actually mitigate a lot of this. And AI powered web security systems, well, they can find out the cyber attack pattern and develop counter attack tools. Warfare systems today, increasingly AI is being built into most of these warfare. So in terms of battlefield transparency, battlefield management, can we because especially in terms of satellite imagery, and how AI can be used, because that can actually make those comparisons and tell you that this could be a bunker, or that could be a thing, and therefore that makes a lot of difference over there. In logistics, transport, target recognition. One of the greatest uses I thought was, in healthcare. Um, Healthcare is when we actually talk of soldiers at war, when the nation is at war and the soldiers are out there. It's very difficult for a doctor to reach the spot where the injury has taken place. And here is where AI can play a very great role. And even doctors many times are at a loss as to exactly what has happened. And with those basic inputs provided by the buddies, I think there is a great application over there in terms of providing first aid, in terms of providing the critical care in the first hour of injury, and bringing this person back to life and energy. Monitoring of threats over security of military personnel. This basically, I'm talking of force protection. And in force protection, again, AI plays a very important role, because protection of the force is very important, because that's the only force you have as a nation. And after that, there's nothing else for you to fall back upon. Therefore, in terms of force protection, in terms of vulnerable areas, vulnerable attacks, possible directions of attack, where are these where have these happened? How have they happened in the world elsewhere? What is the pattern? Is there a distinctive pattern? Can we break the pattern and think of a new thing? So I think all that AR this thing, combat simulation, training, and there are greatest applications could be in language translation. Should I tell you, one of the major problems we're facing today is translation of Mandarin to English. And not us, even advanced countries like US and Europe, a number of countries in Europe are facing this problem, because we actually want to know what are the science and military subjects that's being taught in Mandarin in China, and the variants of these dialects, and how we can try and get this type of translation. So I can tell you my experience in the Northeast when we were chasing a few militants. So there was always a requirement of language translation, because somebody speaks in Nagami, somebody in Manipuri, somebody in something, and therefore, we want to get those. And especially when PLA gets involved, there's a lot of Mandarin that goes around. So we have been facing this, and I think AI plays a very important role. Data from so many sensors, and if you train the model very well, and if you create a good algorithm, it can actually help you in battlefield transparency, in decision making, precise situation analysis, offsetting prejudices, and rational behavior in critical situations. And of course, I think in terms of engineering, in visual identification, contextual advertising, sentiment analysis, and robots, big data, Internet of Things. I think it goes on and on. And I want to leave it to the experts for us today to take us through. So before I come to the keynote for today, I also want to talk about what Sundar Pichai said a few days ago in terms of AI-based images, and how they are actually realizing a lot of these images and data for our maps, for our things. So therefore, I think this is what we're going to do. So we're going to have very soon have our UAVs which are going to you just wear a harness and the UAV will pick you up from there and drop you in CP in about 5 minutes. Because you if you don't want to navigate this traffic for 2 hours and reach a meeting point, you just wear a harness, reach there, leave the harness back there, and the UAV through AI is actually able to navigate and put you over there. So, ladies and gentlemen, I think what I want to do is to call the farthest first, and because he's sitting in the US, I don't know why this brain drain is taking place like this, and why do these people have to leave such a fantastic land like India? But then I think they are our ambassadors over there. They are the ones who are keeping the Indian flag flying. And so, ladies and gentlemen, without much ado, let me call upon Abhishek Chopra to give us his little perception and presentation. Abhishek, all yours.
Thank you so much, Colonel Kuber, and thank you so much, the panel members, for having me here. Great opportunity for me to be part of this session. And a lot of the things that Colonel Kuber shared here are very exciting. I come from the background of aerospace engineering. I've been surrounded in my PhD with a lot of emerging technology, and AI and ML are words that are very frequently used in a lot of research areas. What I'm going to focus today is a different aspect, right? While we know the importance and it is very important to understand the use cases, but it is also important to see how we will navigate the computational challenges that come with AI and ML models, especially when it comes to training and data crunching. So the background of mine, just to introduce myself quickly, founder and CEO of Boson QSI, where we are focusing on quantum computing. So all these AI and ML need some more powerful computers, and that's where we are focusing on the next generation of the computing technology with quantum computing. So I have a small presentation for everyone. I will be able to share my screen once I figure this out. Uh, okay, can everybody see my screen?
Yeah, we can.
Awesome. So what I want to make everybody realize that innovation is the key, right? That's why we are here. That's why we are talking about such emerging techs about AI, ML, and then quantum computing, which will support it. Uh, we feel that we have come a long way in the past 100 years, especially in the aerospace and the defense world. From 1900s, when we had the Wright brothers, we felt we took a big leap in 60 years. But from 60 years to the next 60 years, it's like you can say an incremental improvement that we have done. Because when you see on the right hand side, this is where we have to reach. This is where the technology that we are working on. And all these things that Colonel Kuber highlighted are very essential to reach. So why is that happening, right? From why the past 60 years we have made incremental changes and not some distinct ones? Because even though we are supported by data all around, producing data, interpreting data, analyzing data, the umbrella term for this is simulations, right? So the challenge lies in the fact that these simulations are getting more and more complex. They're power hungry, meaning they are computationally, they require much more resources. And right now we rely on supercomputers, classical HPCs to solve these. Now the challenge there is we have to make choice as an engineer, as a simulation engineer, as a person doing AI ML models. Uh, we have to go for high accuracy, which is the need of the hour, but then it takes huge amount of time. It slows the time for innovation for us. So the choice that we actually take is, okay, can we go for some more assumptions? Can we go for low accuracy, less simulation time? But it compromises us on the safety factor. Now, why safety becomes so important? Yes, we want to do exciting stuff, but there are lives of people involved in this. Just for example, the Boeing example is a great one in the aerospace world, that it was an engineering failure that could have been avoided if we did our simulation or the kind of data that we could have generated to avoid that engineering failure. but we were not able to. And the reason for that is the bottleneck is the computational power. And this is where we are saying that to support the AI, ML, or any other predictive modeling, simulation, digital twin, or whatever you can say, it requires that next generation of computing technology, and quantum computers are the one that can actually provide that power to us and will give us that faster time to innovation and also the safety. So going back to that first slide that I mentioned, instead of making incremental improvements, we can actually make some significant advancements using these emerging tech with the use of quantum computer. Now, what I've mentioned a couple of times, quantum computer. What is quantum computer? It's a different way to see things. Right now, every model in AI that is trained, or anything that we do on our computers or our mobile phones, uh, the machine reads things in the level of zeros and ones. What quantum is giving us is the possibilities, endless possibilities, I should say, between zeros and ones. So we can take 0 0.5, 0 0.7, whatever that is. What it does is inherently is giving us that power to take more possibilities at a given point of time. And I have a very interesting video to very easily explain to the audience and the people here that what actually quantum can do. This is by a professor or a researcher in IBM, which is trying to explain this to a student. So just confirm if you can hear the sound actually. Can you hear the sound?
No, not yet.
Okay, let me. Let me try now. I hope it works. How about now?
No. You have to put more numbers between 0 and 1.
uh, Let me try this again. Okay. So if this doesn't work in a few seconds, I will just move on with the presentation.
Excuse me, sir. You have to stop your screen share and then please share it again with the
Okay.
video.
I see. Perfect. Thank you so much.
Simple Indian solution. Yep.
Okay.
Sound.
Before sharing, you have to select the computer audio as well. There is a checkbox.
Oh. Yeah, I've done include audio button as on.
Yes, sir.
So okay, this doesn't work. Apologies for the. It's not working yet.
No.
Okay. Uh, Yeah, I will just continue. So, what really I'm talking about is, in essence, quantum computing. What it does is basically it takes the mechanics of quantum principles of parallelization and utilizes to do powerful computing. So, what it has been seen, right? This is a very famous chess player who was competing with an IBM machine, an IBM supercomputer in 1900s. And during that time, he was actually beaten by the computer because the computer was able to think 200 million possibilities. Now, the same thing was done with quantum computer, and quantum computer was able to think 5 times more, so 1 trillion moves per second, and was able to beat this chess player. Now, as Colonel mentioned about Sundar Pichai, Mr. Sundar Pichai, the CEO of Google, uh, he also mentioned about quantum and how Google has actually surpassed something called as quantum supremacy. Again, this is a video, so I'm not going to bother anyone with it. But in this video, it explicitly states out that a problem that Google solved and showcased that how it can beat classical computers were like it was a it was trying to identify the number of molecules in this entire universe, which would have taken 1 million years for the classical supercomputer, the best of the best. But with quantum computers, you can do it in few seconds. Now that's the power we talk about. But why am I talking about this? Why do we care about quantum computers right now? And what is this news technology all about? Let's go to our things that we know, aerospace. That's the background we all come from. One of the we're going to talk about two different problems. One is the de-icing problem. It's a very important one, especially when, let's say, our army is fighting in the northeast. You tend to form, or you are in this region, you tend to form ice on the aircrafts. It could be very detrimental to the performance of the aircraft, even at times adverse that it could create accidents. It's an engineering problem at the end of the day. And using AI tools or using more computationally heavy tools for doing, let's say, fluid dynamics, we could actually predict this. But we are not able to do so because of the high computational cost it takes. So what if we start using quantum powered thermal solvers, fluid solvers to find new mitigation techniques in order to do this de-icing problem? So that is one area where quantum can make a difference. Uh, the other problem is structural health monitoring, something which is very important, very close where AI is being used in explicitly in the engineering world. So structural health monitoring is very relevant in composite materials. A lot of our wings that we see in the aircraft are actually made of this composite material. But it is very difficult to do this structural health monitoring because the cracks that can form in these composite materials are not visible to eyes. So something as mentioned like image processing, right? If you have a very good image processing tool and faster simulation, something with clubbed with structured solvers can make a huge difference. So what quantum can do is it can create on the fly results to improve the structure quality, reliability, and safety. So that is some few thoughts that I wanted to leave the audience with on where and how these new emerging technologies need new computers to make a huge difference. So thank you for patiently listening. Happy to answer any questions if anyone is curious about something.
So, Abhishek, thank you so much for that excellent presentation. And I would really request you to send those two videos. We would like to see it at our own time if we can. But then there are so many questions, as many questions as the numbers between 0 and 1. So I think I'd have to leave it for another day. But I must tell you something very thing when you talked about innovation being the key and the speed of innovation and next generation, and do not take incremental incremental benefits. Take a leap. I think I like that point which you said. Take a leap. There should be a transformational change, and I think that can be brought about by quantum computing. And when you were thinking of all that, I was thinking, in the I was reminded of the war, the greatest war ever fought on this earth, the Mahabharata war, where these guys used to, they close their eyes, and an astra used to come in front of their hands. It could be a Vayu astra, Brahmastra, whatever astra. It depends upon how well you concentrate. I think that is quantum computing in their head, and super material technology that was probably available at that time to them. And like you talked about de-icing, I think I should also talk about defrosting. For the ships, as the ships sail, they collect a lot of dust in the sea, and that actually slows down the speed of a ship. I think again AI, I think same, you can do that. So Abhishek, it was a super excellent presentation, and I think we I mean, again I should thank Dr. Nasir Jamal for having caught hold of you from somewhere and make sure that you are awake to be with us today. Thank you, Abhishek, once again. So,
Appreciate
ladies and
it.
gentlemen, from that excellent presentation from the US, from a very dynamic young Indian, anyway, I'm intrigued. I want to ask a question to you. How is the funding? Do you get good funding in the US for any ideas that you have?
Um, I mean, I was here and since my undergrad. And when I went to my PhD, I was supported by my university. Now I have actually transformed completely to be a founder. So I'm supporting myself on what we are doing in the activities in those on this side. But I think so. It's about perception. I work with a lot of Indian professors right now. We fund a lot of Indian students, PhDs and master students. So I think so. It's about perception on where do we place innovation to what level.
Great,
That's the
great,
difference.
great. So, ladies and gentlemen, with that, I think one of the brightest stars of the Code of Signals, and you know, he's been commanding a unit along with one of my very close friends, General Sandeep Sharma, who was the chief signal officer at the time, and he was speaking so highly of him. I said that I should get him because I'd known that he does a lot of work in AI, does a lot of work in cyber security. He's an expert of all sorts and a great soldier, a soldier scholar. And here I call upon Colonel Inderjit Singh Brara. Inderjit Singh, the floor is all yours. Take them through the next generation defense with AI.
Thank you very much, sir, and thank you for having me here. It's really a pleasure. And thanks, Dr. Jamil, for having me on the platform. It's a real pleasure to talk to you on this particular platform on a very niche technology, AI and defense, and everybody does talk of it. And where we are and how we are going to reach, it's a really interesting phase of metamorphic phase we are going through. And just to tell you, I was there last week in my unit, and one of my youngster, he developed AI based tactical vehicle identification, right, where he could bring all the sensors together, identify whether it's a friend or foe, right? And it was a very interesting platform which is developed. And if used properly, that's going to form the major part of C4 ISR, right? So that's the way our Indian Army is really progressing on the AI using different platform, different technology, and all more of in-house development altogether, right? And this is a real motivating part. And where does the AI really work on, and how could the AI advance in national security? It's a real question what we are getting it. And this is part of one of the reports of the National Security Commission on AI. And we all know that the war is going to be AI versus AI, right? And how the AI will change how we defend in future. And we're already seeing that happening. We're seeing bits and pieces of the drone attacks which are there, the swarms which are there, different kind of C4SR, ISR devices which are come up, and how the intelligence agencies are going to make sense of the world and how we're going to fight. So that's the pretty long question and answer what we have to reply to. So the autonomous systems were the part of it. Third war revolution, we have seen it after the gunpowder and the nuclear weapons which are there. And the future war is going to be fought by the AI. That's what we are saying. And the bigger question is, will the human be in charge? We're all moving towards AI, but if the AI is going to overtake human, that's what we anticipate by 2045, are the humans going to be in charge? And it's become a modern, critical part of the modern warfare. It improves the self-control, self-regulation, self-actuation of the combat systems. And it's got real inherent computing and decision-making capability. That's what is the power of AI, what we are seeing. And it's improving the war fighting capability of the country. And we are all moving towards it. And the uses in the AI is one of the major one, and we all seeing is the cyberspace. And we always talk of the Russia-Ukraine war. There we're seeing some bit of it already, where the cyber war is at the forefront along with the kinetic war which is here. The information processing, your unmanned vehicle swarms, your ISR plays a major role. And we talk of the Taxi 3I system, C4I system. We are talking of the C5 ISR systems. The AI is all going to be there in your logistics, your command and control. the major factor which is going to happen is, will the commander be in command to say what decisions to take, or that is going to be driven by the AI? That's a bigger question we are going to be, putting to ourselves, because AI is all going to give you data, give you the analysis, but who is in command of the complete war, right? Your target recognition, and that's where my youngster made a software, pretty good software which can be productionized. Your autonomous vehicles are in thing which are there. We're seeing so much of impetus getting into the autonomous vehicles. Your healthcare, which Kuber sir has already emphasized on, the battlefield healthcare is so very important, and a person who's injured can be picked up by drone and brought back, right? We are already seeing the helicopter drones picking up the people who are injured in the battlefield. And then is the combat simulation training. We are all having the AI getting into it. Your situational awareness, your algorithm targeting, automated planning and the manpower allocation, your options analysis for the capability development. So all are the areas where we are seeing the AI taking the forefront. We're all moving there. And ISR plays are going to play a major role. Second area, we are talking of the drones. And we already kind of moving towards becoming one of the leading drone country altogether. And having the drones for the surveillance, using the AI, we can practically control the complete battlefield, right? We can track enemy movement, we can conduct reconnaissance, we can get into the unknown areas of war, and believe you me, we can also target a particular commander of interest using the drone and the AI and kill him wherever he may be. So that's the power of the drones and along with the AI, which we are going to see, right? In addition, we are also seeing, the swarms coming to the forefront, right? And the swarm warfare is already catching up a lot of impetus when it's coming to the battlefield scenarios which are there. Your AI assisted common operating picture is another area which is important, and the decision making is very important for any a commander when it comes to the AI. And also the warfare platforms are now going to be AI based, right? And we are expected to empower autonomous and high speed weapons to carry out collaborative attacks. It's not going to be fighting a war in silos. We are going to have a lot of data. We are going to have the complete warfare where the performance of the warfare systems will be requiring less maintenance. We'll be able to maintain the supply chain management, your feeding of the weaponry systems which are there, your ammunitions, everything can happen that way. We're already seeing, the autonomous dogs which are being inducted in US Army based on AI. The logistics and transportation is really changing the scenario. The military transportation is also taking a real big shape, right? And we are seeing lots of things happening on that side. Cybersecurity, of course, the lesser said is the better, because cybersecurity is at the forefront now. It's the fifth dimension of warfare. We are seeing so many attacks which can be managed through the cyber AI, and once it's a AI, it's going to be AI against AI. Once you're being attacked by a particular algorithm, the algorithms are going to become so smart that they can redraft, recreate, and re-attack the enemy and launch the counter attack to tackle them. So that's what is the power of AI in the cyber warfare which we are seeing. Target recognition, of course, is one of the areas where we are looking in for the accuracy of targets in a complex combat environment. It's a very interesting space, because today, we generally grapple to find the right target, find the friend or foe, because in the fog of war, it's very difficult, and AI is all going to enable us. And the accuracy levels are phenomenally very high. Like I was telling, there are already people who are working on the target recognition softwares using the AI, and it's got a huge potential, which actually gives the power to the commander to take the control of the battlefield. And of course, the healthcare, we talk of the robotic surgical systems, robotic ground platforms to provide remote surgical support and evacuation, and also the combat simulation and training. So these are the areas where we are seeing the effect of AI on the warfare. And what we've been talking of, the unmanned vehicles. So we have already in place unmanned aerial vehicle, we are AI enabled. Unmanned underwater vehicles, we are seeing unmanned ground vehicles, they're already there. And they are the ones which are playing a major role, and they can be remote controlled and manned remotely from anywhere, and very good effective tools which can be used. One area which is of importance is the C4ISR, which I was just telling you, and the C4ISR plays a major role in today's warfare and also the next warfare. And how the AI is going to help us? It's going to find the needles in the haystack. We will be able to connect the dots, and we can disrupt dangerous plots by discerning the trends and discover previously hidden and masked indications and warnings. And that's what is the AI, which will give the power to the intelligence fraternity in the military intelligence per se. And will also be able to have the complete intelligence cycle of collection, processing, exploitation, analysis, dissemination, will be able to do it all very effectively. And the AI algorithms can actually sift through vast amount of data. They can find patterns, they can detect threats, they can identify correlations and make predictions. And that's where the commander now is in really in power to take right decision with the right amount of data. And AI in the satellite imagery, it's going to play a major role. Your communication signals. In fact, AI is going to be, we talk of the information warfare. We are also going to have the influence warfare, which is most important in due course of time. And influence warfare is all about the warfare on the social media data. And AI is all going to play a major role in the influence warfare. And this we have already seen the taste of it by the Russia when they did the influence operations on Ukraine. And they have huge amount of influence warfare based on AI already implemented in their complete organizations and in the setup, right? And the open source intelligence using the AI is also going to play a major role in the complete ISR. We've been neglecting the open source intelligence OSINT part of it, and that's where your influence operations and influence warfare comes into place. And in fact, I will suggest on this platform itself, while we talk about the information warfare as an organization, which we already developed, we have the DCA, we are looking into it, we need to have the influence operations, right, as part of a different arm, because there's a whole lot of OSINT which is involved in this kind of warfare, right? And we are going to be like empowered by the AI in different, facets of the warfare, and different technologies we can practically use it. The facial recognition, the voice recognition, the NLPs which we are talking of, imagery analysis using the computer vision, and also the algorithmic search which we are looking in for the larger databases. So that's the kind of thing which we are seeing, and autonomous systems are very important today. They are going to play a major role in the AI in the battlefields, and they actually are going to give the strategic and tactical advantage. Actually, you are not wanting, you can actually avoid having the soldiers going to the dangerous areas altogether using these autonomous vehicles. And this is all really happening. This all started moving up, and they can expand the battlefield. You can allow the combat to reach into the areas where it was really you can't go there, and you're accessing that, and you can reduce the casualties. You can reduce the human from being getting a fatal casualties. And this is where the autonomous vehicles are uh, very much fit for dull, dirty, and dangerous missions. They play a major role, and they give a lot of kind of uh, push or the force multiplier for the commanders who are there in the field. Then is the adoption of robotics and autonomous systems, very important. And this is where, they already, US Army has implemented these kind of robo in the Army since 2019, 2020. And this is how you're managing, and this is the power of the AI. Just imagine you're managing the complete robos, RAS, using these kind of tools. It's all powered by the AI, right? And it gives you improved performance and reduced risks to soldiers. You can do new force design. You can do that way. Very interestingly, work on that. And also, you can have the better institutional support to the combat forces altogether with the RAS, right? So I'm not dwelling because of the paucity of time, but definitely we can have much larger discussion around that. I'll move ahead. And the AI, which I told you, comes through the cyber warfare, and it is being used to hunt through the computer networks, and it's a warfare which is AI against AI. You're going to have all the sophisticated algorithms which are going to attack the computers which are attacking you, right? And that's where the AI-enabled cyber tools are coming to the forefront. The cyber weapon, which are AI-based, they are coming to the forefront. Earlier, we've been talking about all the APTs, which are APT 29, 36, 41, all of them which are there. But then now they're empowering with the AI algorithms along with it, which can detect, evaluate, patch software vulnerabilities before adversaries can chance to exploitation, right? And that is the power of the AI to secure your critical information infrastructure, right? That is how it's really going to work. And we're already being seen F-35, one of the best aircrafts in the world, right? But it's also got the maximum number of IoT devices on the platform. And it is, of course, the number one, target for all the hackers today, because the complete supply chain management, the complete, operations management, maintenance is all done on using the IoT, the machine learning, deep learning, and the AI engines which are there. So this is one of the best flying machine. And if you look at it, it gives you all the predictive maintenance instead of the aircraft going back and getting in for the maintenance. It's giving you the autonomic logistic information system, real-time sensor data embedded into it. So this is one of the best aircrafts, but one of the best targets, for the hackers. So just imagine you're flying over the battlefield and the hackers are trying to hack a flying F-35. That's the kind of situation we are going to be. And this is no kind of myth, it's a reality right now. And this is how the complete aircraft looks from inside. Very interesting piece of the data which is being given by the different sensors, but at the same time, it's highly vulnerable, right? And as regards the India is concerned, we have lots of things which we have already done, lots of policies which we have come up there, but there's lots to be done. We have the talent, and like Colonel Kuber said, brought it out. One of the best talent is already there outside the country. So we have a brain drain which is going out of the country. We require these people to make us AI enabled, capable for the warfare in due course of time. The research plays a major role in AI. Your patents play a major role, and AI companies and investment really need to go up very fast, because the way the technology is moving, it's really very difficult to catch up. Only if you're able to have the talent, we have the research, we have the patents, we have the startups, we have the companies who are investing, who are working in collaborative manner with the government and military. I think makes a major push towards getting into the AI. And the private sector is, of course, going to play a major pivotal role in shaping the AI inception into the India. That's how we are looking at it. Also in the defense forces, Make in India push, of course, is the major impetus, which is, or the major area we are looking in for in the areas of aviation, your naval, your land systems, your cyber, your nuclear and biological warfare. So that's what is going to be very important. And AI in all these areas are going to play a major role, and policy and institutional intervention would be very important. And of course, there are lots of work happening in the private sector with the startups, but at the same time, we really need to get that AI for the defense purpose and customize it and keep working. And I'll stop here itself. Thank you very much for your time, sir. Should you have any question, I'll love to answer them.
Okay, thank you, Colonel Indrajit Singh. I mean, in a short span of time, you told us so much. And I'm only reminded of the great Abhishek Chopra, who said there are so many numbers between 0 and 1. And I do not know if I ask him how many numbers are there between 0 and 0.001. I mean, I don't know again how many numbers are there, because we are talking in terms of an infinite domain, the Brahman, what Lord Krishna calls in the Bhagavad Gita, the ultimate, which is unmanifest, which is not known, which is not understood. And he says, try to understand that. I mean, I don't know how we can do it. But I love the way you talked about, I mean, so many things you said, but I think I'm going to talk about one or two things. I love this thing about AI versus AI. It was like a Kramer versus Kramer. And I think we are going to talk about missile versus missile, UAV versus UAV. We are a country of programmers, and I think programming is what is going to bring us into the next generation so quickly, because these contemporary technologies is something that, as a country, as a nation, we are so proud of having such great people. You talked about the brain drain, and I must tell you that I contributed a little bit in my own way to stop brain drain. There's this little girl who was with me, who's an aerospace engineer of sorts, and she wanted to fly away to Germany. She had the wings. I clipped the wings and I said, no, you'll work with EY in India. So she's here. You can see her on the thing here. So the future of war, you talked about how, it's all going to be these robots which are going to fly. And I love that F-35 example which you gave, where the aircraft, it flies by itself, it maintains itself, it flies again and retires by itself. I think I would love to have an aircraft like that, where there is no human intervention. And then you talked about these robots which will go and fight in the airfield. I would like to be in that military where I don't have to go onto the battlefield. I'll send robots, let robots fight robots, and let's see how the war comes about. Well, I think the very, very interesting thing that you talked about, the private sector, you talked about influence warfare. And I think, again, I get back to the Mahabharata and said, both sides had similar weapons. It was the influence warfare which changed the outcome of war. And if you know how the Mahabharata war happened, Ashwatthama Maraha, Kutaha, Kunjaraha, Naraha, and there is a jamming that's taking place on the battlefield, and Lord Krishna blows his Panchajanya, which is the jammer, and that guy Dronacharya cannot hear, and therefore he has to die. And this is influence warfare. As I see it, I think it was great. So, ladies and gentlemen, after that fantastic presentation, I think one presentation after the other have been super excellent today. And I think, I do not know where I would place each one, but I would definitely say that we have one of the greatest companies worldwide, which is into a lot of this. And this is one company which has done a lot of work in India. I visited the facility, the HTSL facility in Bangalore, and I see those engineers, developing patents, having so much of work that they do, especially in aerospace engineering. And I have great pleasure in welcoming Surit Hazra, who is the Business Development Director. Surit, the floor is all yours, please.
Thank you, Cornwall. Let me just share my screen. So can you hear me?
Yes, very much.
Thank you. So I'll give a quick brief of the what we call connected defense, which encompasses I think cyber. It encompasses a lot of basically information connectedness that leads to cyber. And then, as Abhishek mentioned earlier, it also then moves into the quantum domain. We have Honeywell had the opportunity to build a quantum computer themselves, what they call at a volume 64 level quantum computer. And then we have now partnered with Cambridge Quantum Solutions to provide practically quantum level algorithms and services for all sorts of industries, starting from US defense to finance, healthcare, And I think Cornel, you yourself were mentioning that healthcare was a large, beneficiary of quick information exchange. So that has kind of, I think, has already begun in the industry. Just a brief overview of the company, and it's not so much of a sales pitch per se, but I'll come back to why we are mentioning this, especially in a cyber forum. So kind of broadly, aerospace, building technologies, performance material, and safety. The underlying commonality across all these four verticals that we will revisit continuously as we move further is the control systems and the control system architecture. This is where we have played in the last 130 years. And this is the genesis of us moving into the next generation of technology in terms of cyber, or rather connected cyber. So we have the control system architecture experience. We are now moving above that to the output of control system and how we can connect information that arrives at one layer of the control system, moves to the other layer, from an asset level to an enterprise level. That applies to a helicopter as much as it applies to a petrol refinery. Typical aerospace portfolio, again, which we will again connect with our connectivity services, would be electronics, engines, mechanical components, and a bunch of things on the top right corner here, which is connected services, connected systems, data analytics, and cybersecurity. All of them are in one form or the other interconnected in their roles. A very set of key platforms, as I think Cornel Inderjeet was also mentioning. F-35, yes, the predictive thermal management system is Honeywell's, but amongst them there are a bunch of platforms that we are doing. Now, this is a slide, I think, which kind of summarizes the rest of my presentation in brief. What are we doing with all that hardware, engines, and sensors and systems that we had made? We are moving on from that into autonomous, energy sustainability, artificial intelligence that includes robotics, and certain use cases which we are kind of seeing in air and gas detection, energy storage, etc. It is yet to fully percolate into defense. One of the things that is major in defense is sensor intelligence. That is also providing you the information which goes into the bulk that we are going to use for cyber. Edge intelligence, which is 5G essentially. Then there are smart materials, which is again materials that are essentially antiviral, packaging, and all of that. And then comes the big kind of overlay, which is quantum. Further down that, you have distributed computing, spatial wave computing, and cybersecurity. All of these are essentially, in a sense, faster computation, algorithmically complex, uses a lot of data that emerges out of systems that are in various, be it aircraft, be it industry, etc. And at this point, it is, as I think Colonel Kuber mentioned, force multiplier, etc. It is not asset level. It has to be enterprise level. There's no point in just an aircraft controlling, contacting the base. It's the base contacting the swarm, the fleet, all of them, and even in an ideal world, the aircraft contacting with each other, the UAVs contacting what we, in a grand view, we anticipate as network-centric warfare in a very specific defense. So that is where we are kind of trying to step in. Advanced sensing is essentially about sensors which are intelligent, next generation MEMS, things that are providing data that are real time, providing data that are customized, all of that essentially happening in that. Autonomy and AI, a total control of an unmanned air system, starting from power generation, electric motors, even including what we have, traffic collision awareness. So you have traffic collision, you have ground proximity, all of that together is an integrated system, for example, called aircraft environment simulation system. So the UAS himself, largely while flying, will start taking auto decisions, not completely auto. There are reservations of obviously an UAS being completely auto. None of them, even the Predator is not completely auto. But a large portion of the decision making has to be on board. Secondly, you have connectivity. SATCOM, again, large vehicles through small UAS. We have small form factor SATCOMs that are manufactured for small drones from larger applications. An use case of that, all of this that I mentioned, is in an app. In an app, you have airfield ground lighting connectivity, you have aircraft asset tracking, you have whether the aircraft has visually docked control, you're controlling air traffic management, and you're controlling the asset, which is the building management. In a computer app, you are essentially what we call connected airfield. Your entire airfield, starting from the air side to the runway side to the buildings, the passenger side, everything can be controlled. That is at one level leveraging the control system architecture onto a cyber platform. Smart facility, smart base. Connect that with what we call smart procurement, smart materials management. All of that is again leveraging your essential material management skills, your essential warehouse sensing skills into a cyber domain. Capture data from every source. Have a plethora of sensors, as Cornel Singh mentioned, plethora of sensors all over. Basically, an Internet of Things architecture to capture data from every source and then intelligently process that data to become to provide conclusive results. Connected maintainer, the person who's working, that has to be they have to be connected with the entire repair chain, the entire MRO chain. Automated Google Glass kind of applications, automated headset kind of applications that automatically annotating texts that is giving the maintainer a hint as to when one step of the production is over, which table should the item land in the next, what are the checklists that are coming in, everything in connected practically to his brain. Flight line security, something that is used by a lot of US Air Force, etc. Perimeter management, aircraft airtime, and flight sky management. Then comes basically cyber, again, which is whole integrated solutions. Asset, as I mentioned, asset to enterprise. A cyber protection of the aerospace assets, cyber protection of the platform, cyber protection of the base. So you have to connect every item to each other and to a co-hosted central network. In the cyber solutions, you have end-to-end cyber solutions, for example, which is starting from remote access, file transfer, which is also encryption, starting from asset discovery, managed security services, and then cybersecurity consulting services. Because we understand the technology that we are talking about today is not really a please send me a budgetary quote and your best price kind of a situation. Those are applicable to screws, nuts, bolts, and boxes. This is a partnership deal. We will provide the framework and we'll provide the architecture. We will sit across the customer and their subject matter experts, the armed forces, the DRDOs, and then let them tell us how they would like to customize our system. There are certain places where they will not even allow us to venture because of security reasons. There are certain places where we will provide them the infrastructure to encrypt and let them devise the encryption themselves. The old school, very traditional RSA algorithm style of encryption kind of technology. Increased risks of cyber attacks at digital plants. We are more and more going to strategic places, power plants, petrol refineries, hospitals. All of these are essentially hot places for cyber attacks and hot places for cyber protection. Solutions that can mitigate. You have a core control system, the core engine, what we call, engineers love to use this word called engine. So core engine running at one building, and then the modules are basically spread out, each of them talking to the building at a faster pace at very, very high rates, and with all sorts of centers of excellence. The cyber on a chip. This is again a miniaturized version where you basically, if you have seen, and this is becoming prevalent in the Western world now, slowly coming to India, a lot of people have wallets which are RFID protected. A bunch of debit cards and credit cards are in that wallet, but you cannot run an RFID scanner to actually get his number. So it basically makes your credit card, debit cards dumb in that environment, and thus protecting any spamming. The cyber on a chip is a situation where You have a small chip connected inside an aircraft, and it basically creates a ballistics cover, and I would say a cyber ballistics cover for all your active ports. As Colonel Singh was saying, that there's a big hacking that's a risk of the entire, starting from supply chain to the aircraft in larger IoT devices. These cyber chips are meant to make those IoT devices encrypted. They won't. It is not a jammer. Your IoT devices are alive and working. It is just unhackable. Then obviously at the tactical edge, any kind of platform can use the security. And finally, the way we look at the connected cybersecurity is you have smart building, you have physical systems, actuators, etc., which have a lot of information and getting interconnected in systems. You have process automation that can happen in advanced plants. You have safety automation, warehouse efficiency that's kind of happening. Cloud to aircraft, navigation map. For example, we used to give, and Karan Kuber is aware of this, we used to give CDs. Every 28 days, you give CDs for updating nav database on a computer. Cloud-oriented databases. EFB, emergency, the flight board, which earlier used to be a pilot diary, then it got strapped on the thigh of the pilot because of making it in an iPad kind of thing. Again, moving to cloud. The electronic flight bags, what we used to call. And then obviously the next gen combat vehicles, which already comes sensor heavy. The idea for us is to then use that sensor architecture and provide the platform for each of them to talk to each other, as well as talk to different assets. Again, asset to enterprise. Potential collaboration areas are platform, fleet specific integration opportunities, scalability, everything is kind of there. I think this is pretty much what I want to say, but I want to use this platform more and more to let the audience know. The aim for this presentation was to let the audience know the capability that exists with us in our technologies based on whatever heritage we bring about. We would like to partner, we would like you to talk to us, and we would like to talk to you. CAIR, for example, we have already provided details to CAIR. We would like to talk to them more. We want to understand what you need. This is not something where I can send you a brochure and expect a purchase order from tomorrow. The idea here is not so much to sell. The idea here is to partner. And the same applies to Abhishek Sevaplu. We are in technologies here where we need to talk to understand what our capabilities need, how can our capabilities to serve. I don't know how they serve. You have to tell me your infrastructure, your sensor placements, your objective, your encryption level, who you want to talk, how many people you want to talk to, whether you have a control room, whether you need encryption, which is public level, whether you need encryption that's purely private. It's your own traditional network, right? For example, the GNSS or IRNSS versus normal Inmarsat satellite, etc., etc. You give me spec. Our teams, both serious looking engineers on both sides of the table, will sit down. They will exchange their traditional topics, and finally something will emerge. A pilot thing will emerge at a small scale, and maybe then it will be replicated. So I think the conversation needs to happen more. It needs to go beyond opening a so-called a council or a program or a national movement, etc. We would need some sort of the organizations from both sides, the private sector, where I belong, Abhishek himself belongs, and the public sector, who has the infrastructure to partner, who's the first line of defense with the armed forces military, to kind of join hands. So I hope this session and similar sessions with PHCCI actually enables that. We have seen it earlier in the hardware domain. We hope we see that and multiple times more in the cyber domain. Thank you, sir. Thank you.
Suri, that was so excellent. You transported me in an AI domain back to Honeywell. I visited Phoenix. I actually saw the engines being made in your Phoenix facility in Honeywell. I saw the engine testing over there. I visited HTSL. I mean, I'm one of those guys who's inspired by HTSL, the amount of work that they do in India. And I like the last comment that you made. It's all about knowledge. It's all about the capability that exists with Honeywell, and you're keen to partner. The only question which I have for you over there is, once we start partnering, will there be issues of ITAR? And then, this US always is a very difficult country to deal with. On one side, they'll talk a lot, they'll come, they'll shake hands, they will have everything with you. And when you actually talk business, they'll say, oh, no, 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 that's ITAR or something like that. Do you think some such issue will be there?
See, again, sir, in this, as I said, I think we are giving the framework. The partner is developing the actual offering, number one. So therein that itself, and then more than my ITAR, I think the Indian Defense MOD will have his own encryption and privacy, etc. Because it has to be sovereign. I cannot have a server outside, etc. Like what we saw in BlackBerry, for example. So the data sovereignty, etc. The second point is, I think, from a larger perspective, I think US has also, in a sense, learned that the ITER regime has watered down, and you are a witness to that more than anyone else here. The ITER regime has watered down largely. Of course, there is a license, and when you go to a country when you go to a country and asking them to share technology, etc., that concern will be there, even if India shares it to Bangladesh or somebody else.
Yeah. I totally agree with you. And I mean, it applies to me, it applies to you. If somebody asks me some question, I normally don't answer it in full. I mean, that's how transfer of technology takes place. I think that was excellent. And I love the way you talked about enterprise level, interactions rather than asset level. And you gave so many examples over there. You talked about the Honeywell connected airfield. Let me tell you, I visited your Hyderabad facility where I actually saw this. I mean, it was an inspiring thing where we actually saw this connected airfield over there. And you talked about smart procurement. When you said plethora of sensors, get data from everywhere and get conclusive results, that is where I saw there was a contradiction. When you have so many sensors, you get data from everywhere, you can never have a conclusive result. And in spite of IoT, I mean, I don't know, but I thought that was a little bit of a dichotomy over there. But then yes, it helps you hopefully in decision making. You talked about cyber protection platforms, assets, end-to-end solutions. Very interestingly, you talked about this. It should be a partnership deal, and it's not about screws and bolts. And where you talk about L1, I can actually, Suri, get you an appointment with the Director General Acquisition. Please go and tell him this. I wish he listens to you. And I mean, I don't know how the MOD will react. Oh God, L1, oh L1. And for L1, you'll get only that much. But I must tell you, when you talked about cyber on a chip and wallets protected, this was, I think, again in those years of 2011-12 when I visited Pentagon. They had no issues for us carrying the mobile inside. I was quite surprised because it won't work. They have a way of disabling that. Either you carry whatever you want by, but nothing happens in the land of Uncle Sam. So I think that was a very, very good thing. And you talked about migrating to cloud. And Surit, once again, it was fantastic interacting with you and Honeywell. And we are having one after the other superlative presentations today. And it's my time to call the keynote speaker of today, Dr. Lakshmi Narasimhaya. Lakshmi Narasimhaya Garu, welcome. Namaste. Please come onto the stage. He is a scientist F at the Center for Artificial Intelligence and Robotics. And if I get the name right, Lakshmi Narasimha Garu is from the same place that I belong to. And every third guy over there is a computer wizard, and either he's in the US or is somewhere else. But they're all talking computers and living computers. Dr. Lakshmi Narasimha, the floor is all yours, sir.
Yeah, thank you. Thank you. I'll share my presentation. I'm audible?
You are.
Yeah. Garu, yeah, it's fine. It's a more Andhra name, but yes, I belong to Karnataka. In that sense, yes.
Okay.
Okay.
Chennagide.
Chennagide. You're able to see my screen? Okay. It looks like it's cut into.
Yes, we are able to see your screen.
Okay, let me try this. Okay. So, fine. The AI actually gives both deja vu and nostalgia, the way I see it. Okay. So, in that sense, now we see it as AI prefixed and suffixed everywhere. Similar thing happened to cybersecurity, and it continues to happen with another AI tag to it. So the way we perceive AI as a designer, engineer, the way we see it is AI transformations have happened partly because of the growth in the hardware. And then, yes, the techniques remain the same, fundamental techniques remain the same. So it gives us a little bit more power to harness that data and give you out results. So in that sense, do we have enterprise level functioning AI today? There I have my own question marks. Beyond some big companies owning the entire internet space where they tell you what they can do, beyond that, I don't see AI being delivered to the masses or even the enterprises as we all aspire AI to do it. So that has become still a difficult art to get into. So one of the classic examples have been our Watson system, which has been talked about with much hype when it won the Jeopardy. And subsequently, when it was put on domain-specific tasks, it did not give us desired results, and it saw its own downturn. So AI has this hype cycle about it. Like everybody feels AI can be done, but it is a niche area. It requires niche technologists to work on it to deliver AI. So the one thing that is happening today is the availability of data is only in the internet space, not in the enterprise space. And one size fit all type of solutioning is what is being attempted that may not work in all areas. And more so in military applications, we have a problem at hand that's different altogether in the sense that we have a disadvantaged network space, we have a disadvantaged data space, and then still we are talking about delivering AI. There, the solutioning becomes slightly more complex and tricky. So in that context, what I'll give you a broad overview on what are the possible, how do we contextualize this AI? So do we understand the problem, at least in the defense per se, how do we contextualize this? So broadly, as the definition goes, endeavors of artificial intelligence are to develop intelligent systems. So when we say intelligent, we want it human-like abilities to interact and learn. So how the way we define intelligent systems is it should be able to represent the domain of activity, perceive the state of the world via inputs, and reason and achieve its goals. So simply put, many times what happens with AI is till you do some task and achieve the goal, people see it as AI. Once we do it, people say, ha ha, isme kuch nahi tha. This is nothing. This is just, it read out some input and it gave some output. So that is a classic problem as AI researchers we face all the time. We work hard to reach a goal and then finally they say, "Ha, re, ye to kuch nahi hai." So those are the issues which we face with AI. So then, now what is it AI? Let's contextualize some of those definitions which we always see everywhere. Narrow AI, task specific, perform repetitive task. I still feel this is an area where we are still in the narrow AI space. Of course, there's a lot of promise about having an artificial general intelligence type of an approach where it can do everything like a human does. There are some theoretical formalisms, but I don't see it materializing as yet. And similarly, then going one level higher than that is a super intelligence space, which is again talked about. It's good to be having researchers and PhDs, and we progress the technology space. But having a promise on the field, I would not do at this stage. So then, what is the role of AI? At least in the defense space, where we want to contextualize is, can AI replace human? We don't recommend that as far as defense goes, AI can replace human as yet. So we would only say maybe a routine task, some level of automation which might be required. There is a scope for doing it. But yes, investing in so much for do we have that payoff? Maybe it's limited, but it can still be done. But replicating a human part is still a feasible, but this doesn't require any too advanced technology. So to say, expert systems were there from many years now. If we could model the domain adequately, we can still have some experts replicate it. But again, this is not for combat roles. What? Why? Because we don't expect predictability in those roles. So we want some uncertainty. We want some strategy, tactics, and various other things. So with that, yes, so possibly we don't have manpower resources. We want experts at different places. We want some routine decisions to be given out. Maybe we can try there. Yes, reinforcing human is a possibility. Thoroughness and speed to the human. That is one area where one could exploit AI. and also augment human skills together and use it as a sort of a wingman to the use. That is one part. And then coming to how do we go systematically develop this system? One of the fundamental things required for doing it is the data platform itself. And now when we talk about connectedness, availability of sensors and various other things, in defense forces, it becomes too complicated. We have multiple vendors, we have multiple sensors, we have multiple platforms, we have multiple forms of data coming in at different abstraction layers and different formats. We cannot gel all of them together just because I have a compute platform and put all of them and just ask a question, and it definitely gives me an answer, but that answer will be as good as whatever it is. So in that sense, unless we work bottom up in all these things, we will not be able to see any fruits out of our efforts in that direction. So we need to work on these data formats, annotations, and various other things. And one other aspect in defense procurement or even defense development we always face is we need to go into a model of iterative development, which is not there existingly in the defense area. So we need to build layer by layer. We should be able to compose them. We should be deploy, try, again, reiterate on that. Unless if you go a build to spec model and then an AMC or you want to do an ATP on that, maybe we will not be able to deliver an AI system which will give you that type of a results. Because the problem here is not per se the AI. How do we set out expectations on the AI system? So that is fundamentally is a problem for both researchers, developers, and as users and industry has to come together and set that expectations right, get the common vocabulary correct, and then build it around it. So that is a tall ask. It's still we are yet to cross. And then the continuous updates, and this is another. Once say we crossed all these hurdles and still we built a system. Now when the system is at the user hand, how do you update those systems? How do you bring in those changes either in the algorithmics or in those models? These are trickier questions. So this needs to be worked out, and that's been our continuous endeavor to work with all the defense forces and try to see build systems in them in whatever way possible, and try to how do we inculcate that habit into them and try to reiterate. That is what we are trying again and again with them. Let's see. And then comes this evaluation and feedback. For us, that there are two types, right? One is human in the loop and human on the loop. So mostly human in the loop is what is it for defense today? Human on the loop in a limited sense. So then one of the important part of accepting AI is you should prioritize speed or perfection and proof in decision making. If speed is your priority, and then you should look upon AI, that's when I say it should be human in the loop. And then you should build AI into the defense forces. Then possibly we can look for AI uh, becoming one of the useful tools for our defense forces. But if we aim for perfection and proof, which possibly the technology cannot provide you, and even if you strive hard, we will not be able to achieve you, because the fundamentally we are fundamental fabric of the system itself we are trying to change by asking it to be perfect. Once it is perfect, it can only give you one answer. So you cannot expect multiple answers from a system. So we have to understand how the system is and what type of technology you are trying to inherit and what is expected out of that technology. And evaluating the effectiveness and in-depth training, of course, it goes without saying. So we may have to do all this. So that's what, as I was telling, the challenges are there. We have to have multiple data sources, canonicizing those formats is a challenge, and real-time sensing, processing, control. Yes, the platforms are there. Some of them are there as COTS, the commercially off-the-shelf ones, and some of them can be built. But yes, we have our own challenges in terms of terrain, in terms of our networks, in terms of our various other issues, whether it should be centralized, distributed, our command hierarchies, various other things come in here. So before we even identify what is our best mechanism to address these type of issues. And then, of course, the human-machine interface, we can have interactive bots or domain-specific languages can be built. As a technology, it exists. Whether we can materialize it for the defense forces, that in itself is a challenge. Of course, the knowledge extraction part itself, each and every of our military users carry lot of domain. They will not be able to articulate in the way as engineers and researchers expect them to. You have to engage them continuously. You have to listen to them, whatever, even the lower JCOs, NGOs, they also carry a lot of it. So you should listen to them. Once you listen to them and then bringing it to a form where it is machine readable and human perceivable is a bigger challenge. So that endeavor takes long incubation. So we should be allow that incubation and build technology upward. We cannot keep changing technology day in and day out, at least in our military. So military technologies require long incubation times, and you should continuously support them, build them upward. So of course there are techniques to extract knowledge. These days it has advanced. So we have, as designers, we have tools at our disposal, both learning wise and rule based tools. Of course, the other challenge always the military is about certification and verification, which we face even in our cyber systems or even a normal automation systems, which we get into military. Of course, safety is a concern. That's when I said that if speed is my criteria, if proof of correctness is not what I'm looking for, then it becomes slightly simpler to come out with some of these guidelines and push the system into the system. But otherwise, it becomes a problem. Then the policy evolution itself, the change is not that easy. I cannot update policies day in and day out. That is another issue. Of course, the societal and legal issue, machine take over job loss. If I speak to a person and अरे मैं क्या करूँगा अगर machine सब कुछ करने लगा? So then I have to answer him. Then he will not give me the inputs required, so that he feels that, oh no, threatened, no, अगर ये machine ने करने लगा तो मेरा काम ही नहीं रह जाएगा. So these are some of the other issues which will be there. So when we work with defense forces. Okay, and technology enablers, as I was telling, we have technology formalisms. Knowledge representations has been there for years. Machine learning has been there, and neural networks has taken a new avatar in deep learning, Bayesian reinforcement learning. Reinforcement learning has been talked about in games today. So these are all there as a tools for us to do some uncertainty handling recommendations. These are good. So these are purely for designers and researchers, not to do with the users. But for materializing all these, we need a framework to do with it. Similar to the game theory, the infrastructures are also there, but how do we network them? How do we inculcate into our own defense forces? It itself is still a challenge. Of course, policy, anyway, I did mention standards, data formats. It's been talked about now. Somebody mentioned about AI task force. Yes, these things have been discussed, but still it is a work in progress. So let's understand why it is, what has changed. Say what so far, how do we build defense for systems these days? We capture all the requirements, design them with a complete system, build, test, and deliver, right? User qualifies it upfront and takes the system as it is, reports bugs. So this is nice, assuming static conditions. What has changed then? If you build the learning type of a framework into this system, what changes? Initially, based on whatever data sharing and domain sharing, I can build you tools, built into the system. Then the user will put the live data into it, and he'll process and outputs are consumed. The user has another role here. He should update his models. He should update his knowledge. I should enable him there also. Then his requirements to not only using the system to updating the system changes. And then, of course, the updates to the fundamental framework by the designers itself has to be there. Then the availability of real data during design, that is a bigger challenge. I cannot expose something else in the first development phase, and I expected new data to be given altogether and expect, ye to AI ko karna chahiye. That type of a thing will not work. So these are some of the things. And as far as care itself, so what did we do? I'm only asking questions. We have a sort of a simple workflow type of a thing just to depict to you all. We do the scoping of the problem, and we do the whatever the learning design scoping, and then we need some production partners to work with us for implementing that. We do work with them, and we have these type of layers like 2 and 3 we participate, 2 3 5 we participate, 5 and 5a 5ab we participate more, and the 3, what is the implementation, maybe the industries also, we leverage them in whichever capacity we can to help us out in doing that. So that is some sort of a model we are trying to attempt to see that, yes, we can push AI into the defense forces and try to give them that continuity which is required and build in an iterative manner. So this is sort of a breakdown of that frame itself. If you see the green areas are the normal data handling type of a solution. You have those frameworks. Maybe industry also has ready-mades for it. But then all the blue ones had to be built to the user. So this is where it creates a little bit complications, which we try to come up with frameworks and work with the defense forces. So that's what we are doing. And then the other aspects are the cognitive systems itself. Here we talk about an end-to-end system which can do everything. So maybe a robotic system is one type of an example here, or even a missile system. Built for a specific profile, some users configuration input. Earlier, that's what is currently being done, invoke the profile, and it follows the mission parameters, predictable execution is done, and you accept it. Now, the problem comes in a current scope. If you want to scope it in a larger cognitive system type of a scoping, then we have to max scope it. Now max scoping it and then enabling system mission to take decisions where it traverses the path between human in the loop to human on the loop. So these are some of the gray areas which creates more complications in these type of cognitive systems. So this we have also created a framework. Somewhere there was a RAS, we call it as Mars. So for our own military, we have done this. We have a multi-agent robotic framework which will do it for us. We have an algorithms and all the places, and we have small terrestrial bots built, custom built for military for this. This works like a team given a task, and they will perform the task. And I think some TOT with industry is also being done for this. This is how the just a control station for the type of bot is also there, which can done heterogeneous activities. So now coming to how do we target a use case? So we should understand where are we? Why do we need AI? Where do we need AI? What are the type of problems we need to address? So these type of things we have tried to put together some sort of a questionnaire and try to see to help the designer in some space, to help the user in some space, to understand where he's coming from, what is his intent in answering, so that we can contextualize it, we can bring in a certain expectation. So that is broadly it. I'll not go into the specifics of it, basically to say that what are the types of areas that it will cover, what are the type of data we need to gather, and what are the type of systems we need to build into the system. So that is what we are trying to work with. Again, this is all work in progress. This is not nailed and completed, neither there's a standard documentation for it. We are continuing to work with users and refine ourselves to see that we meet some of these some of our own objectives of delivering useful AI to the military. So I think that's all I have in terms of what I can say. But one other thing is also there. Yeah, this is important. Now the question comes is, say I deliver AI system. Now, who will take accountability for the AI system? So this is largely the problem, right? So now, how do we take? You have a weapon system, yes. Now there's a distinction between a weapon user and a weapon maker. So if what if AI gives a wrong decision? Will the commander be responsible for it or not? So these are some of the tricky questions. So then we always feel that yes, if it's a military command hierarchy, it should be with the command control hierarchy. Adequate training is required. Yes, it should be induction. If you are inducting at that level, yes, it should be selection based on potential and rigorous training by users. We have to evolve towards moving in this to materialize any useful AI in the military parlance. So I think that's what I have to say. If you have any questions, I'll take it. I'll be happy to take it. Thank you very much. Thanks for giving this opportunity.
Dr. Lakshmi Nasamaya, that was excellent, very, very informative, and I think I would call it as a session in education for us, to see as to what care is done and how you are actually bringing about and thinking about a problem. So I want to take it from the last one, what you said, who's responsible? I think the commander will be responsible. After all, AI will give you only those results which has been fed to the AI. As a good enemy, I'll always feed what I want you to see, and I want you to hear, and I want you to think. So the enemy will always feed certain things, and AI will give out the results in that manner. And therefore, I think we need to have the commander at the end of the day, who will have to take this. I like the way you said it gives both deja vu and nostalgia, and I think I think you're so very right, and in the niche areas, technologies, I agree that availability is on the internet and not at the expertise level. So one can do anything and people will still say, ha, ye to kuch bhi nahi tha. I think that was so right, because the other day I was talking about, the Prithvi launch, and I said, you see, we have done this. Oh, ye to theek hai, ye to karna hi tha. Because I think today we are looking at DRDO or DRDL, or the Integrated Missile Development Program in that manner, that well, we are the best in the world, and I think we have to do it. So I think in the same context, it is not that what you did or what you do maybe is significant or not, but the fact is the expectation of the country from DRDO, from CAIR. I think that is the faith that people have got in the system, and I think you. I mean, as DRDO today, we are actually able to see that lot of delivery is taking place, and today we are talking about our LCA being bought by a few countries. We're talking about our BrahMos. We are talking about our radar, Swati. I mean, I think we are doing a lot. And you talked about the cognitive system, and I have a comment: awareness of own state. I mean, that is one thing we all need to be aware of if we want to live properly in this world. Awareness of our own self and awareness of our own state. And of course, you talked from the point of view of AI, and that's excellent. And the execution paradigm was very, very well laid out. And I think those questions are so relevant. So, ladies and gentlemen, we are coming to the end of a very illuminating and educational session on AI in defense. Let me tell you that Indian Navy has recently awarded 10 defense research projects to Andhra University, most of them based on AI. These projects are related to AI, cybersecurity, etc. Bonvi Technology, a homegrown startup from Odisha, has developed the first AI-powered electric aircraft, which is clean, smart, sustainable in transportation. Paras Aerospace has developed Paras.ai drone information technology product. Bell signed an MOU with the Army Design Bureau for collaboration in AI. Hyderabad-based HC Robotics is researching, designing, developing, and partnered with IIIT Hyderabad and IIIT DM Kurnool on stabilized gimbal cameras, AI, and advanced technologies. Indian Navy Technical Training Institute, INS Valsura, has organized a workshop very recently on leveraging AI for the Indian Navy. Distinguished academicians from IIT Delhi, New York University, Amrita University, DICT have all spoke about the latest trends and applications in AI over there. Located at Jamnagar, it's been designated as a center of excellence in the field of big data and AI, big data analytics. Indian Navy has also formed a AI core group, which meets twice a year for assessing AI ML initiatives. Microgenesis Technosoft, Bangalore-based a company that enables clients to capture and interpret spatial and geographic data, has entered into a technology collaboration, and DRDO has transferred Microgenesis, the technology, for its indigenous geographical information system developed by CARE. Ladies and gentlemen, it has been an excellent session, and Dr. Lakshmi Narasimhaiah, it was, it was very apt that the keynote was very illuminating to all of us. And once again, I need to thank Abhishek, Surit, Colonel Indrajit, and Dr. Nasir Jamal, and our great team behind with Sachin, who put all this together. And ladies and gentlemen, I want to hand over to Dr. Nasir Jamal to actually conclude the session. Thank you.
Thank you, sir. Thank you, Colonel Saab, for and indeed the discussion, the whole webinar was very, very illuminating and wonderful discussion. I myself was wondering, how what AI is going to do in future, how the warfare and everything will shape up. Even my virtual existence can happen later on, maybe. So this, it was really engrossing, and I was listening to all the presentation. That was really, really delightful to listen to all of you. Thanks, Abhishek, joining from US. It's time to sleep for him, but he's still there, joining with us. Thank you, Mr. Dr. Lakshmi Narasimhaiah, the scientist from CARE. Thank you for joining, Mr. Surit Hazra, the business director from Honeywell, Mr. Indrajit, Colonel Indrajit Singh Barara, and obviously the moderator for the session, Colonel K.V. Kuber. Thank you, all the dignitaries. We also thank the Technology Development Board for facilitating and supporting such a wonderful series of webinars. Even we would like to thank the Ministry of MSME for supporting, extending their logo support for these series of webinars. We know that the technology has become the key driver for the pace of evolution, and the incarnation of AI is motivating obviously the global powers to prepare themselves to control advanced technologies, and with the goal of establishing their dominance in the power play. And so India is actually now following the pace, and we look forward that we see many more milestones in AI in the times to come. Thank you, sir. We look forward to a series of more meaningful interactions with TDB and with other Ministry of Defense and Ministry of MSME and Ministry of Home Affairs in the Homeland Security. And we'll be uniting all the stakeholders from Indian defense industry for such a wonderful interaction. Thank you so much. Thank you all.